television station, wherever you might be, or perhaps you're listening to a radio simulcast tonight. My name is Sedge Thompson. I'm in Philadelphia with scientists and astronomers here this evening. The no audio that comes up on the screen, by the way, is put on by the JPL television studio, referring to the fact that there's no audio as part of their broadcast. However, there is clearly audio with ours. That's just to make sure you aren't being fooled by something that's being put on the screen there. We were first seeing a picture of Triton in a very large shot, and then it was going to a wide-angle lens. NASA scientists could see, while we could not, stars behind the planet, and that was being used to help navigate and determine the exact position of the Voyager 2. We're going to be taking some telephone calls here, and this first one is Phil from Illinois. Good evening. Welcome to Neptune All Night.
Good evening. I wanted to take a poll of what your panel's best estimates are as to how many years at the very earliest it'll be before we can expect to see a Voyager-type Pluto probes picture on our TV screens, and how many more years after that until Viking-type planets and sizable moons of our solar system.
Well, I think that the person to talk about that will be the strategic planner from NASA, the Office of Spaceflight. Although you deal with manned spaceflight, you also know about the unmanned projects.
Well, I happen to know that a Pluto probe is not on the immediate plan of the space scientists. Apparently, they do not consider Pluto right now important enough for this multi-million-dollar project. They have a number of other projects which they would like to prefer, the Cassini probe, for example, and Mars rover sample return. They do want to fly to Pluto, but in connection with what they call the 1000 AU mission. They have a super mission in mind for the years beyond 2000, which goes out of the solar system, out to 1000 AUs, or astronomical units. And in doing so, it will fly by Pluto, sending back pictures from Pluto, and then go out for the next 50 years. It's going to take it 50 years to go out 1000 AUs. But that's a very long-range mission. We are still maybe 20, 30, 40 years away from that. And I haven't heard of any concrete plans for a Pluto probe before that.
All right. And Michael Abacher?
We should probably point out that 1 AU is equal to the distance from the Earth to the Sun, something like 93 million miles. Neptune is approximately 30 AUs away. So when you think about that, that's 3 billion miles, that 1,000 AUs is an incredible distance. Pluto, unfortunately, was not in the right place at the right time to be included on this journey, and it would have been nice if it were so that that Voyager could continue to Pluto, although we should also point out that Pluto is now closer to us than Neptune is. Everyone learns...
This is because of the shape of its orbit.
Because of the odd orbit that Pluto has, and its angle to the ecliptic, that Pluto sort of sneaks into the orbit of Neptune for a 20-year period. So from now until 1999, actually, Pluto will be closer to us than Neptune. The image just changed.
Derek Pitts, I noticed you looking at the image.
Well, we just had an image shift from the last image that was received from Voyager 2. We were looking before at Triton, and now it looks as if we have a very close-up picture. And I'm not exactly sure what this one is yet. Jessica, do you
I
have
think I know what it is.
That's Neptune again.
So we're right up onto the
Neptune
cloud tops of Neptune?
Right.
These clouds are, I believe, about 30 miles. The methane clouds are 30 miles above the blue surface, the blue layer of clouds, and that's what's causing this shadowing effect, what it looks like here, a three-dimensional effect, because the methane clouds are so extremely high above. They had some wonderful pictures in this afternoon of this nature also.
It's about 78,000 miles away from the center of Neptune. So that picture was taken a considerable time before the closest approach. We always should remind people that we are talking about a time difference of 4 hours and 6 minutes.
Now, is this then a photograph that's being sent from the tape recorder that's on board Voyager then?
Yeah, no,
That's why it's come up now?
Yes. Right now the tape recorder is being played back. At least, it was, 4 hours and 6 minutes ago.
A question I have about this image is these clouds that we're looking at, are these the clouds that appear white?
That's right. These are the methane white clouds.
The ones that scoot by real fast?
Right, and they believe now that they are approximately 30 miles above the blue layer that we see underneath.
We have as a guest here on the telephone James Glick, a former writer of science issues for the New York Times and author of Chaos, making explains a principle that many scientists feel is actually what is organizing our solar system. Welcome to Neptune All Night, James Glick.
Oh, thank you.
Could you briefly describe how chaos, I don't know if explaining how chaos can work can be done briefly, but what has been surprising about finding the storm in Neptune's surface, and how do you explain this in terms of chaos, in terms of weather we might understand here on Earth?
Well, one of the very big surprises has been the discovery that Neptune is a very turbulent, dynamical place. It's surprising because it's so far away from the sun and it's so cold that astronomers had thought it was going to be pretty dead. What we're talking about, of course, is weather, otherworldly weather, and on Earth, the weather is very much driven by the sun. It heats the ground, which heats the air, and most of the motion that we're used to in the atmosphere here comes from that kind of heating. Our imagination about what the solar system is like has been very much preconditioned, of course, by our experience here on Earth. But it's turning out that things are not the same on the other planets. And Jupiter, of course, we've been watching these beautiful pictures tonight, has this now famous turbulence, the eddies that you can see, these whirls that look like turbulence in a stream, and the Great Red Spot. The Great Red Spot is described as a sort of storm, just like the spot on Neptune is now being described as a storm. But storms on Earth are very transient things. They come and go in a couple of days. The spot on Jupiter has been there for 400 years, which is 400 years that we know of, that is, since Galileo first saw it, and for all we know, for millions of years. It turns out that chaos specialists have managed to explain the spot as a dynamical process, sense that we know it on Earth, but a sort of giant whirlpool that sits amidst the chaotic turbulence of the atmosphere of these planets.
What might, if a human being were standing on Neptune, what would that storm feel like? Would there be winds? Would there be some sort of, do you have any speculation about it?
Well, it is very much like a storm on Earth. That is, it's swirling winds in a cyclonic motion like a hurricane, except in the opposite direction. But of course, it's many times larger than any storm on Earth. We've heard different estimates, but big enough to swallow up the planet Mars or big enough to swallow up the Earth. It's too soon to say whether this is a storm like the one on Jupiter that seems more or less permanent, or whether it's weeks or months or years. I don't think there's enough evidence yet, but it's this gigantic vortex that is stable in the sense that it's in the same place, and yet chaotic and turbulent in the same sense that any storm on Earth is chaotic.
Any further insight into your knowledge of chaos?
Well, of course, the solar system, the heavenly bodies, for a long time were the epitome of order for scientists. It was the regularity of the motion of the planets, the predictability of their motion that really gave science its start. It's only recently that we've also begun to appreciate little bits of chaos in the solar system. And another example, very different from these storms.
Well, thank you very much, James Glick, for illuminating for us the storms that are going on Neptune. With pictures from space and voices from Earth, this is Neptune All Night.